In the last video, we discussed about how do we test whether two variables have a linear relationship or not in population by using their correlation coefficient from the sample. Okay. Now, suppose that in the population, the two variables x and y have a linear relationship. Now, what we want to do is, what is the equation of their relationship? What is the linear equation for their relationship? How can we represent that in a line? Okay, so basically we will try to find out a line of best fit, or we call regression line, or the trend line. Okay, and that line could be useful if you want to find out the value of dependent variable for a particular value of independent variable that is not given from the population or from the sample. Okay, let us see. So to study the relationship between two variables, we collect the data, okay, and construct a scatter plot and determine the type of relationship the variables have. Also, we evaluate the correlation coefficient R and test the hypothesis. That's what we did. Now, we find out the correlation coefficient is significant. In other words, if we reject the null hypothesis, meaning rho not equals to 0. If we find the correlation coefficient is significant, meaning if there is a linear relationship between x and y in the population, the next step is to determine the equation or a line that represents the data points best. Okay, the line of best fit, also called regression line or sometimes called trend line, is a line that goes through the most of the data points or close to them. In other words, the regression line is the regression line is the one with the sum of square of the error minimum. Okay, so what we do is, suppose you plot the x and y data, xy data. This is one point you got, that is another point, another point, another point. So you got these dots. Now you draw a line that goes through the middle of all those data. That means that goes close to all these data. So in this line, the difference between this point and that point, 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 square of the difference will be the minimum in the trend line. If you draw another line, let's say that goes like this, that goes like this, then the error or the difference between this point and that point, square of the difference between all those will be bigger, because the line of best fit has the difference. Sum of the square of the differences will be smaller one. That's what the line of best fit has. Okay, so the regression line are very useful to see the trend and make the predictions on the basis of the data. So formula for the equation of the regression line is y dash or y prime equals to a plus bx. Y prime, this is for the sample. Okay, these are for the x and y are the values of the samples. Okay, and a and b are called the coefficients of that. So b is the slope, a is the y-intercept in this case. So how do you find out a and b from the sample? This is the formula to find out a and b from the sample. Okay, guys. Now, here the thing is, and y prime is y-axis. That's what the y prime means. It's just a prime. This is just a notation, but it is y-axis or y component, whatever you say. Okay. All right. Now, the thing is, we don't want to use, we don't want to find out this by hand. You can find out this by hand. If you want to do that, you need to do x and then y and then xy, right? Because there are xy's, xy, and you find out x square and then find out y square, right? And then plug in those values there. So x values will be given to you, y values will be given to you. You find out other values there. Okay, so you do that. But the calculator, do you remember that when we did calculator, it was giving a and b values? Those are those a and b values. Okay, so if we use calculator to find out a, b, and r values, actually we don't need r for this, but we will need a and b only, and then plug in that here in this equation. Okay, and then we will find out any values of y for given x. Let's see some examples, but before example, let us talk about that. We use the same table and values from correlation coefficient to evaluate the values of a and b. So we get the same table here. Okay, and the a and b values are calculated by this formula. Now, so b is basically the r value, right? See, so n times summation xy minus summation x summation y over n times summation x square minus summation x square, but the denominator is different, the numerator is the same as r. All right, in calculating the values of a and b, we round up to 3 decimal places. All right. So let us look at the note. Regression analysis involves finding the line of regression y equals to a plus bx. To decide whether we should or we should not do the regression analysis depends on the values of the table I that uses alpha, degrees of freedom n minus 2, and the sample regression coefficient r. What does that mean? That means before we tested the hypothesis, right, to check or to test whether the x and y variable in the population are related, or whether there is a linear relationship between x and y variable in the population. So if we reject the null hypothesis, that means if we support that rho is not equals to 0, that means there is a linear relationship between x and y. But if you do not reject the null hypothesis, meaning rho equals to 0, if you support rho equals to 0, then in that case you don't have to do the regression analysis. Okay, so if the sample correlation coefficient r value is greater than the critical values or less than the negative of the critical value, then you do the regression analysis. Otherwise you do not do the regression analysis. Okay, so we know how to reject or don't reject the null hypothesis. We'll do this example first. Let's see this example. The number of murders and robberies for 100,000 population for a random selection of state are shown. First, test the hypothesis for the significance of the correlation coefficient. Okay, and the no regression should be done when r is not significant. Okay, with alpha equals 0.05, then find the equation of the regression line. All right, so this is the data from the sample. The murders, let's say x, and robberies, let's say y. Does the number of robberies depends on number of robbers or not? Number of robberies depends on number of murders or not? That's what we are going to test. And also it says find y when x equals to 4.5. Look at that. There is no 4.5 given for x, right? But we will find out y equals to a plus bx, y equals to a plus bx, and then we will plug in that, we'll find out a and b by using calculator, and we'll plug in that x equals to 4.5 to find out y. Okay, so let us first test the hypothesis. What is r? To find out r, what we do is we clear this here, and then we enter the data first. Hit enter. Let us erase what we have, clear that L2, and then clear the L1 as well. Okay, so oops, sorry, let me clear them and hit enter. Okay, now let me enter the values of x and y. So 2.4, and then 2.7. Okay, so we enter the data here, right? Okay, now one of the things you should be careful is you never mismatch the order, okay, because they are coming in pair. For example, whenever there are 5.700,000 murders, then at that time the 5.7, that means this is the 5.7. At that time there are 95.8 thousand robberies and so on. Okay, so this is how they come in pair, so you should not mismatch those. Okay, 5.7, 95.8, this is that one, right? And the other one is 6.6173, so 6.6173, 6.6173, and so on. Let us find out r. How do we find out r? Is go to the stat and then calc and then ax plus b or a plus bx. Okay, so let us go to a plus bx here. A plus bx is number 8, so you can do ax plus b, no problem. Whatever you pick, that equation depends on that. Okay, so if you do that, then you will get a plus bx. But if you do number 4, you will get ax plus b. Okay, so let us enter that. You get L1 is x value, L2 is y value, and go to the calculates. So you get a is negative 13.15. Okay, so a is negative 13.15, b is 25.33, and then r squared is 0.64. so r is 0.804. So r is 0.8042. So 0.8042. It looks like there is a positive linear relationship in the sample at least, right? But we don't know about the population. So we want to test whether that is true in the population or not. So critical value, we need, what is alpha? Alpha is given as, let's see, alpha is 0.05. Well, how many pairs are there? 1, 2, 3, 4, 5, 6, 7, 8, right? So the degrees of freedom is n minus 2. So alpha is 0.05, and degrees of freedom is 8 minus 2. That will be 6. Okay, so what we do is go to the table. Go to the previous table we had. So table is 0.05 and then 6 degrees of freedom is 0.707. But we take both plus and minus, okay? So what we do is 0.0707. So critical value is plus minus 0.707, okay? So the correlation coefficient, what we got, 0.80 something, right? Let's see. The correlation coefficient 0.8042. So R is 0.8042. So what do we get here is, let us make a T table here, or the T curve, right? That the critical values are negative 0.707, 0.707 and positive 0.707, right? And how about the regression value? Regression value falls here because it is bigger than 0.707. 8042 is here, right? So we reject the null hypothesis. We reject 80. Reject 80 means, what does that mean? That means we reject 80. So we reject this one, meaning the rho is not equals to 0, meaning there is a linear relationship. There is a linear relationship means we need to do the regression analysis. If you do not reject that, you don't have to do regression analysis, okay? Now let us copy the value of A and B, negative 13.151. So y equals to A plus bx, right? Let's see. So I want to write that y prime equals to A plus bx. So we got negative 13.151, negative 13.151, and then the value of B is 25.333. 25.333. That's what we got. You see that? So what do you get then? You plug in there. So negative 13.151 plus 25.333x. Okay. So what we do here is, if you want to find out the value of y or y prime when x is 4.5, you plug in that as 4.5. You replace that by 4.5. That value will be 4.5. So what do you get? Is negative 13.151 plus 25.333 and then times 4.5, okay? And then use calculator for that. Use calculator, you will get negative 13.151 plus 25.333 times and then you get 4.5. If you do that, you get 100.8475. That is 100.8475. That is, you can say 101, okay? Because it is the number of robberies and number of murders. That's why y is number of murders. So if there are 4.5 thousands of robberies, murders, then at that time there were 100.84 thousand of murders. You can predict that way, okay, depending on our findings, okay? So, and again, as I mentioned, you can get linear regression of ax plus b instead of a plus bx, okay? So you get the opposite value of a and b here. You will get this is b and this is a. So if you do y equals to ax plus b, y equals to ax plus b, you will get a equals to that b value because b is the coefficient of x. Here a is the coefficient of x. You will get 25.33 and then you will get b equals to negative 13.151. For the same data, if you pick the different linear regression, for example, let's say go to calc, and if you do number 4, ax plus b, this is what you get. Okay, all those are the same. This is what you get. A is 25.33 and then b is negative 13.151, right? That's what you get. So, but exactly the same thing. And in this equation, you will write y equals to a plus bx. Instead of a plus bx, you will write ax plus b and plug in x equals to 4.5. You get the same thing. Okay, guys? So, exactly the same way to do the example number 2. Alright? First of all, you test the hypothesis. Find the correlation by finding the correlation coefficient and the critical values. Do you want me to do that? Let's try that. So what is alpha? Alpha is not given, so we'll take alpha equals to 0.0. Let's take 0.01. Okay, so let's say this is given 0.01. 1. Okay, so alpha equals to 0.01 given. So here what is H0 is rho equals to 0, meaning there is no correlation, and H1 is rho not equals to 0, means there is a correlation. So that is number 1. Number 2, alpha is 0.01. What is the degrees of freedom? Is 1, 2, 3, 4, 5, 6. So degrees of freedom is 6 minus 2, that is 4 degrees of freedom. Now how do I find the critical value? Critical value will be, so we need to look at the table, right? So look at the table with 4 degrees of freedom and 0.01. Okay guys, 0.01, 4 degrees of freedom is 0.917. So 0.917, let's do that. So we do plus minus, the critical value is 0.917. So what is the correlation coefficient? Number 3 is correlation coefficient is denoted by R equals to, we plug in that in calculator and find out that from the R, find out that from the calculator. Okay, so go to the stat and then hit enter. So I want to remove all the previous data, and I want to remove that one as well. So 25, 25, hit enter, 23. Okay, so I entered the data in the calculator. So to find out the correlation coefficient, you should do stat and then go to calc, okay, and then go to linear regression. I am using ax plus b now. So if I do that, I get, so these are the values of a and b, and this is the value of r. R is negative 0.54, okay. So r is negative 0.54. What else? 5426, okay, 26. So what is happening there is, so the critical values are negative. So here the critical values are negative 0.91 and then positive 0.91, right? And then where does this fall? Negative 0.54. Where does that fall? Negative 0.54 will fall here or here? It will fall here, right? So negative 0.54 actually falls here. Okay, so in this case actually you do not reject the null hypothesis, right? So number 4 is do not reject H0, meaning there is no linear relationship, because we accept that. We do not reject means we accept that there is no linear relationship. So no linear relationship, okay. For alpha equals to 0.01, there is no linear relationship. What that means? That means you don't have to find out the regression line, okay. You don't need to find the regression line for alpha equals to 0.01. We cannot answer this question, okay. So we cannot answer this question because there is no linear relationship. So we cannot write y equals to ax plus b or a plus bx, because the hypothesis said there is no linear relationship. So we cannot answer that question, okay guys. So first of all, to find out the regression line or to do the regression analysis, first of all you need to test the hypothesis to check whether there is a linear relationship between x and y. If you reject the null hypothesis, then there is a linear relationship. If you do not reject the null hypothesis, then there is no linear relationship, so you don't have to do the regression analysis. Okay guys, thank you.